Right. Okay. I've got the good session, of course, all about coatings. Sorry? It's true. And first up, we've got Willem. Willem is the segment manager for wind and energy at AzkoNobel, protective coatings division. He spent 14 years in the paint and coating industry, covering several roles in technical, commercial, product management and marketing. Originally from South Africa. Can't remember if they beat us at rugby last time. He spent several years in the Middle East and is now based in the UK global office. And he'll be talking to us about coatings that can be designed to last the life of the asset. So,
thanks so much.
Willem, over to you.
Right, there we go. Good afternoon, everybody. Just before I kick off, Darren Ward helped prepare a lot of this information as well and worked quite a lot on this. Unfortunately, his schedule had a bit of a conflict, and I won the prize to be here today. So I'll be presenting this for you today. Right. So as David mentioned, we're talking about the development of coatings to last the life of the asset. So, as you've heard, I'm Willem Horn. I'm not going to introduce myself again, so we can move on to that one. So, these days, when we talk about sustainability in coatings, the discussion tends to always turn towards what is the VOC levels? Are we focusing on zero VOC or low VOC? Should we be focusing on water-based products? And what about solvent-free? Now, as we know, based on the current technologies available for these type of products, some of them do tend to have some drawbacks. Things like extended drying times, requiring force cure, and some of these products just is not as durable as the traditional coating systems. Now, granted, they do have good sustainability credentials, but these tend to look at the time of application, which, as we've seen today and heard a few times, if you look at the overall life cycle of an asset, that's actually quite a short period. And if you need to go and recoat and repair these type of assets every 5 years, every 10 years, that gives quite a big impact on sustainability over the lifetime of the asset. So the question is, would designing a coating that actually only needs to be applied once for the entire lifetime of an asset not be more sustainable? We don't know the answers, we're just raising the questions. So if we look at what the market is looking for these days, so typically we see that we've got 30 to 40 year lifetime expectancies. Some are actually even going above that. We're all talking about reducing the overall environmental impact. We're looking for proven reliability, minimal requirement maintenance, and shop productivity. So in essence, we need a coating system that will meet or exceed the life expectancy of an asset with minimal to no maintenance. Now, how, from a coatings perspective, is it possible to deliver such performance? Now, what we've done is we've looked at the history and looked at the proof of performance. So we can see that we've got a long history for high build epoxies utilizing glass flakes in the offshore environment. We've also seen that the type and the level of glass flake that is used in these coatings do have a big impact on barrier properties and abrasion resistance. And we've also mentioned it a few times today, if we look at the ISO 24656 standard, which is focused on the cathodic protection for offshore wind assets, it stipulates that utilizing a coating that's got higher than 20% laminar glass flake content do provide the longest service life expectations. So, luckily, a few people today have mentioned the ISO 24656 because I know it might not be that familiar to everybody, as it was only released last year. So we've covered a few aspects of the standard, and as you've seen, as this is specifically focused on the offshore wind structures for the submerged and buried areas. Now, let's look at the coating side of that and why that is important. Now, we are all used to using, we've got the NORSOC standards, we've got the ISO 12944 standards, we've got the DNV standards, you know, there's quite a lot of overlap when it comes to these type of coating specifications. And here, if we look at the ISO 24656 standard, we have the 5 coating categories. And as you can see, between category 1 and 4 for the durability of the coatings, we have already the DNV standards covering some of it. We've got 12944 and NORSOC covering some of those standards. But if you move to the right of this table and you see category 5, now this is where we're looking at exceptional durability in this specific type of application, utilizing the minimum 20% glass flake laminar content. And you can see that none of the other standards covers this level of performance requirement for this type of application. So what exactly does that mean for us? So if you look at the results for the coating breakdown factors, which Winston mentioned as well earlier, is you can clearly see that when we look at the category 5, which is the 20% glass flake content, the performance compared to the others are quite substantially better. Now, this is great on paper and in theory, and we can discuss and argue this all day long, but what does this actually look like in practice? Work with me, come on, you can do it. Let's try, there we go. So here we are now, let's talk a bit about the Hutton TLP case study. So this is a tension leg platform, which was owned by ConocoPhillips. The construction started in 1982, and it was commissioned in 1984. At the peak, it was producing 34 million barrels of oil, and the production ceased 17 years later. So in 2002, it was towed away. The topside was removed and recycled and was actually used on a different asset. And since then, the jacket has been stationed offshore, off the shores of Scotland ever since. Now, you might be wondering, why am I talking about an oil and gas asset when we're talking about wind offshore structures? So the reason for that is the systems that we use and the environment where this asset was is the same as our offshore wind structures. And it is exposed to the same environments and the same conditions. So here you can see, so this is just what the Hutton looked like 40 years ago when it was really launched. You can see that this is the tension leg platform. So let's focus specifically on the splash zones. And like I said, this is what you will typically also see on offshore wind assets. So the coating system that was applied in 1982 for this was a thin shop primer, 3 coats of heavy-duty glass flake coating, which contains 33% laminar glass flake, and a cosmetic finish. Right. So what we did was, after it's been sitting off the coast of Scotland for 30 years, we went and did our first inspection. So this was jointly done with Chris Jordan from Conoco as the coating specialist at the time, to see what it was looking, just to do some visual inspections to see how it fared. And we could see that the original coating that was applied in the splash zone was still in excellent condition. And Chris was quoted in saying, "It's clear that after nearly 30 years in service, the highly loaded glass flake epoxy is still performing very well on the painted tubular splash zone areas with less than 1% corrosion creep." And this was after 30 years already. So then towards the end of last year, they decided to completely decommission everything else that's left of the Hutton, and we went back and did another inspection. And this is now after this has been exposed to the harsh elements for 40 years. And because they were completely decommissioning it, it allowed us to bring in a third-party lab element, to do some proper analysis, some in-depth testing on different samples to see really, truly besides just visually what these coatings looks like after 40 years. And I'll just be going through some, just a few of the tests that was found. So as you can see on the left-hand side, this is a cross-section of the coating system, and this is 40-year-old coatings that still looks intact. The basic ones that we always think about is our adhesion testing. So on this as well, as you'll see, there's 2 sample references. So we did take samples from 2 different areas of the Hutton just to get a good benchmark. And you can see that the adhesion values is well over 10 megapascals. And I mean, even for new coatings, this is quite good. And the adhesion failure was actually not with the steel, but it was with the top and the mid coat. So from an adhesion perspective, the coating system, the scheme held together in some of the harshest conditions for 40 years, applied once, no maintenance, no touch-ups, just as is. Another test that we've also done is the electrical impedance spectroscopy. So here we also had a look at the 2 samples side by side to look at how the barrier coating side of the coating performed. And as you can see, just for reference, if we're looking at a panel that's been coated and not exposed to the elements, you're looking at values of 10 to the 12th. And even after 40 years, you can see that we're sitting at 10 to the 10th and 10 to the 9th on the 2 different samples, which is well above exceptional performance for this type of coating. And again, this is 40 years sitting out in the elements, getting beaten down every day. So what we can see here is that we're talking about low maintenance solutions utilizing high build glass flake epoxies, which has been proven time and time again in offshore environments. These coatings use high levels of laminar glass flake in accordance to the ISO 24656. And you can see that even at, unfortunately, we can't test it any longer because it's no longer there, but the performance level of the coatings after 40 years is still exceptionally good. And if this stayed out for longer, it would have performed even longer. So if we start talking about things like Bert mentioned earlier this morning, when we start considering coatings perspective, when designing these type of offshore structures, this could have helped to reduce the overall steel requirements for it. If we knew that by utilizing the coating, it would have given this level of performance. And also following what Winston was mentioning regarding the CP protection, is that if we, again, from the start knew that utilizing this type of coating with the high level of glass flake content, that we could have adjusted the CP, which over the last 40 years would have contributed significantly to the overall sustainability of the Hutton. So this just goes to show that there isn't just one right answer. We cannot say that let's rip out all the solvents and just use water and that is the solution for everything. There's a lot of elements that we need to look at, and again, we're not talking about the time that it's applied and the product supplied, it's dried, and let's move on. This is, we need to focus on the entire lifetime of the asset and the overall environmental impact from day one until year 50 and year 60 and so on. So just a special thank you to Jonathan Townley, Nerida, and Element Materials that helped us to prepare all the samples and get all the testing done. There's actually a few of our technical team here today as well, which worked quite a bit on gathering all those samples and slaving over the immense pieces of steel that we had to deal with. So thank you to everybody here as well. I actually brought with me, some of you may have seen it, I brought a piece of the actual Hutton TLP with me. So that really heavy, tiny slab of yellow steel sitting in the room upstairs, that is the 40-year-old coating that we took off the Hutton TLP. So feel free to have a look, try and pick it up if you can. I've been dragging along with me all along, so yeah, so the arm's getting good exercise. So yeah, if you want to come and have a look and see up close what it looks like, you're more than welcome to, and to come have a chat with us later today and maybe even tonight. And that is my presentation. All right.
Thank you, Willem. Questions? Trevor?
Well, that was really good, and I'm very interested in the whole subject and many other subjects. I was involved in the CP design for the Hutton TLP, and there were all sorts of problems with high-strength tethers and potential shifts and goodness knows what. But I'd, tell me if I'm wrong, was that an AzkoNobel coating that was on there?
Yes.
Because I've heard the same story from International. Maybe I've got them crossed up. And I got a copy of the paper that you showed there from International Rep.
Yes, so AzkoNobel International is part of AzkoNobel, so yes, and in fact we've done fingerprint testing on the samples pulled from the Hutton, and it is still the same product we sell today. Absolutely. Great stuff.
Thanks, Trevor. And any more? Any questions?
Yes, I've got a question over here.
Where? Oh, hello, Chris.
Yes, it does. Who do you need to convince that it's better to look at the sustainability in a sort of holistic sense rather than just getting rid of solvents?
Honestly, it's not about convincing anybody, because at this stage we're still trying to convince ourselves. It's a moving target. As we know, technology is evolving every day. The water-based products that we were working on 15 years ago is not what we see today. The solvent-free products that has been banned for utilizing really harsh chemicals in order to rip out the solvents, that's not what we see today. So it is constantly evolving. There's new technology coming out. And like I said in the beginning as well, is we're not saying that's the answer. We're saying it's an option to consider. And we need to keep developing, keep working on it, keep trying to find the perfect solution for the overall sustainability. But we have a bunch of different options, and we don't need to, we shouldn't just get stuck on it's VOC levels and solvent or bad and those type of things. We need to really think a bit wider to find the right solutions.
Okay, time for one more. Here we go.
It's a comment to what you were asking. So volatile components, the challenge here is that you have regulations on how many, I'm sure you are aware. And I've just seen that in many countries, Germany, US, it's not possible to produce a lot of foundations for an offshore wind turbine at the rate you'd like to without hitting the roof on how much you can emit. So I think from regulator side, something has to be done.
Absolutely.
Otherwise, the volume that we need to produce is not doable.
Absolutely.
Yeah.
I mean, a perfect example is we have a customer that insists on utilizing water-based coatings. And we said, fine, we've got a brilliant water-based coating for you. Let's go for it. And they spend 2.5 megawatts drying that asset because you know, it's great. It adheres to, you know, it's zero VOC, it's no solvents. I mean, it ticks all the lovely boxes. But, you know, we always sort of forget about the rest of the project and whatever else is required to actually get it out the door. So, yeah, you're absolutely, and that's what I'm saying is I can give you a perfect product. You're going to reapply it every week, but I mean, you know. But that's what we're all striving to, and why we're spending so much time and effort in R&D. I mean, that's what we're here for, yeah?
Stephen.
Obviously, surface preparation is always pretty important for coating application. Were you able to confirm from the element testing, the original profile, for the blasting, etc.
So what we have been able to establish is that it was the steel was fully blasted before application, and that is actually the primer that you see there is a shop primer that was applied before they applied the heavy-duty coating. So yes, it was proper, and that is a very, very key point. This was a properly prepared product in a yard and done according to the specifications. Because as we all know, surface preparation has a massive impact on your overall performance. So yes.
So the shop primer wasn't removed?
So this was a non-zinc thin shop primer that was applied, and it's actually, you'll see there's a tiny little layer of it still in the cross-section of the coating, so it was still on there.
Okay, brilliant. Thank you, Willem.
All right, great stuff. Thanks so much.